Yeah, hi, everyone. Thank you for joining the sixth Ballerina community call. I'm Sam, and I'll be moderating the call today. So just before we get started, I just wanted to kind of take you through a few points on how you can get involved with the Ballerina community and then talk to you a bit about how these community calls work. So let me just get started with that. Okay, so everything to do with the Ballerina community is any information regarding that is available in our community repo in the Ballerina platform GitHub page. So if you want any information about any of our past calls, that includes recordings and slide decks and any resources that we use during those calls, all of that information will be available to you in this folder. So a few ways that you can engage with the community. We have a Slack channel with over 1,000 users that you can join. And our development team is very active on that. So if you have any questions regarding the language, or if you're working on any projects and bump into any issues, then you can raise them via this Slack channel and the team will get back to you very quickly. If you want to get involved in development discussions, you can join our Google group, and you can also ask questions on Stack Overflow by using the Ballerina tag. If you do want to get updates on Ballerina like releases and any content that we publish, or if you want to keep track of any of the events that we speak at, then you can follow us on Twitter. Our handle is at Ballerinalang. We also have a periodic newsletter that goes straight to your inbox where we kind of curate content around Ballerina and also like wider topics like serverless, microservices, gRPC, and things like that. So you can subscribe to the newsletter via this link. And all the past newsletter editions are also in this page. So I'll tell you a bit about the community call in a bit once I get to the slides. Before we get to that, I wanted to kind of tell you how to contribute to the community as well. So you can create content around Ballerina. This can be written content. You can record yourself talking about Ballerina, and you can publish it onto your own personal blogs or even to external publications. You can also speak at meetups or conferences and other events, and even host your own events. And we can help you out if you do want to do this. You can get in touch with us at contact@ballerina.io, and we can help in any way that we can. We can help with giveaways, with training material, and things like that. So do reach out if you have any opportunities, or if you want to kind of write or talk about Ballerina in any way. You can also directly contribute to the language. So you can either report an issue, you can publish a Ballerina module on Ballerina Central, you can contribute to the source code, or you can even contribute by starring our GitHub repo. So all of the relevant links are in this repo. I'll send you guys the link to this via the chat in a bit as well. So if you have contributed in any way, we would love to know. We would kind of like to appreciate it. And if it's a piece of content, we'd like to promote it via our channels as well. So if you have contributed in any way, you can fill in this form and let us know, and we'll be in touch with you. So let's get back to the slides. Okay, so a bit about the community call before we get started. So it's a monthly meeting. We usually have it on the last Tuesday of every month, but this might change depending on holidays and things like that. But it's usually the last Tuesday of every month. So the community call structure, we have somebody from the development team who will go through either one or multiple features in the language, and they will then go into a live demonstration of those features. And then we'll open up to a discussion. So during the session, whoever's on the Zoom call, please do stay muted. But after the session, you can unmute yourself and kind of have a conversation with either the presenter or any of the other attendees. If you're on YouTube Live, then you can send in any questions via chat and we'll raise them here as well. So the recording and the slides will be published on our YouTube channel, Ballerinalang. I'll also send a link to the slides via the chat, both on Zoom and YouTube in a bit as well. So you can check out all these links right away. So useful links to the community call. So we have a working doc that we update every community call. This will have links to the recordings and also any information regarding the invitation and the agenda of upcoming calls. And then we have this notify me form. So if you are interested in keeping track of these community calls and you want to be specifically added to our calendar invites, then you can fill in this form and we'll make sure that you are notified in advance of the community calls when they have been scheduled. We also have a topic suggestion form. So if you do want to contribute to the community call, either by, if you have done something with Ballerina and you want to do a quick demo during the call, or if you want to suggest any sort of topic that we should be talking about, then you can send in those suggestions via this form. Yeah, so that's basically how you can kind of get involved with the Ballerina community. Today we have Anjana here to speak about services and network communication in Ballerina. Thanks so much, Anjana, for doing this session. Over to you. Thanks.
Great. Thanks, Sam. Let me share my screen. Okay, great. Hope everyone can see my screen, right? Okay. So in today's community call, so this is the agenda. So we'll be talking about the new like updated services and network communication like constructs we have in Ballerina. We have done some updates to the syntax of how we define services in Ballerina. And also there are some updates on the protocols we support as well. For example, we have like added new the GraphQL support, which actually works on top of HTTP. In this session, I'll actually go through the new changes and also do some demos, like hands-on sessions on HTTP services, GraphQL services, to see how things work. And also, I'll also briefly go through the concurrency model as well in Ballerina. This is somewhat related to the network communication aspects as well, especially in relation to the non-blocking IO features. So I'll briefly mention the connection between those aspects and like provide some insights on how things work under the hood. Yeah, after everything, we can discuss more as well on the topics. So, so starting with Ballerina services. So I'll start with the basics. So in Ballerina, we have a services abstraction in the language itself. So it's one of the entry points to a Ballerina program. Along with a main function you can define, you can also have services as well. So if you define a services object in your module that is attached to a specific listener, they will be initialized and started up when the Ballerina program is, the module is initialized, basically. A service object. The first thing is it attaches to a specific listener object. That's how we say this is of a specific type of a service. So they can be HTTP, gRPC, WebSocket, and so on. So those basically say, okay, what kind of a service I'm going to define. Basically that's so from that we it mandates the the required like remote methods that should be in a service object. So for example, in WebSocket, if you attach to a WebSocket listener, that service object should have, well, actually, so some of the remote methods it can have, for example, on text message and so on. So there's a list of remote methods that you can use in that way. So basically, in that way, so it's when you are defining that service, it is aware like what kind of remote methods that should be there and that is allowed to have as well. And also a service object can have both remote and resource methods. So earlier we only used to have resource methods. So so every service has these set of resources you can define your functionality. So this has been split into two. This has been brought in especially because not everything is a resource in a service. So we wanted to have some increase the functionality in the generalization we have to facilitate this concept of a remote method as well. For example, in gRPC, what we have are remote methods basically. So in RPC style services, we can't call them resources. So that's why we extended this abstraction to have a remote method as well. So in a remote method, we say the methods are named as verbs. So like you are doing something, so it makes sense. Okay, you named it as verbs. And the resource methods are basically it's used to model RESTful style services. So these resource methods are naturally named by nouns. So that's the case in like the general our HTTP services we can model in this way. GraphQL as well. So those type of services will have these resource methods. So we'll start with an HTTP service to show the new structure that we have. So we still have obviously the service keyword to define the structure. After the service keyword, we have the service name. Now, in this case, the service name also has some meaning to that service's behavior, depending on the type of service. So in the HTTP case, the service name here actually defines the base path of the service. And so this is the listener object, so that it binds to. Here, this is where you basically mentioned if it's an HTTP service or gRPC, WebSocket, and so on. So you can give bind any type of supported listener object here. And then we have in HTTP we have resource functions. So a resource function, something that is new is this resource accessor. So that basically signals how we, from the outside, how we are accessing this resource. What's the what's the way of accessing it? What's the approach? So the accessor can be in the HTTP case, the HTTP verbs that you use to access it, like it can be get, post, put, and so on. So this is again dependent on the transport you are using, the service type. So different meanings for different types of services. And also then we have the resource name. So in the HTTP case, this resource name is actually the path of this resource. So this can actually be a hierarchical path also, which I'll show in a bit with an example. So the name again has a meaning, a specific meaning in an HTTP service. And also another update is we can now directly return values from the resource function. We can say like return string, like a set of supported types are there, like integers, strings, record types, and so on. And also optionally HTTP response object as well, if you want to add some further information. Um, so this makes it easier for like simple resource function implementations. You can directly return that without a problem. So I'll just do a quick demo with that scenario just to show how that works. We can say creating. Now these HTTP caller requests earlier, these were mandatory. Now these objects are optional. We can either have one or both objects or nothing at all. And so only if you need it, you can use it. So okay, and say, just say hello. Say Ballerina. Yeah, likewise. So now as you see, that's how we basically do a simple service with a resource that is supported by the GET. This accessor. So if you by any chance if you have multiple, in the case you want to support like multiple accesses for a single context for some reason, it's a rare scenario. In general case, you wouldn't do that. You can again duplicate this and say like this also. Then for each scenario, so that's the uniqueness is defined by the accessor and the name. So you can do it like in this way also, or if you want a single one to have everything, you can just say default default as well. Then any method, HTTP method used will actually come here. So yeah, if you want, like if you are doing like a pass-through scenario or anything like that, that may be useful. So the next one is the hierarchical resources. So basically, as I mentioned, now in the resource function name, you can actually give the full hierarchy where the resource is actually situated, how it's dispatched to the resource will be defined here. So we can say, we just say, now it lives on, let's say, yeah, base to base. Now it will live on slash base slash foo slash bar. Oops. Oh, slash base. Likewise. So basically, with these we have removed the dependence on the like the annotations we had earlier. So we had tried to like generalize and put the language constructs as much as possible these features, by balancing the general features we put, because obviously we can't put everything here. So things like still security parameters and so on, still the services support the annotations. So those kind of configurations should be provided in that way. These are like added just to make the service abstraction more clear while supporting multiple transports. So with the hierarchical resources, the other one is so in this each resource path segments, we can parameterize them as well. So these can be given as like normal function parameters. So these are called like the resource path parameters. Any value given to this path segment will be passed in as a parameter to the function. So let's see this scenario. So here we say so we want to call /person and we are passing in an int. Let's say it can be some kind of an ID. So let's just simply print that value. So likewise, you can see now that value is passed to the path parameter in this manner. So likewise, you can also pass in multiple values for that as well. So that means so you can have multiple path segments providing values. So here I'm going to give multiple values for these IDs. So we call this REST path param. So you give it's similar to the REST parameters syntax we have in normal functions. So I'll just say so likewise. And with this functionality, you can also make sure we have we can make sure that we have a single function, resource function, which dispatches all the subpaths, subcontexts in a specific base path. Like for example, if I want to say everything starting with person and all other subpaths should be dispatched here, I can say. So here I have restricted to int. If I just say string, that means effectively everything will be under /person will come here. So if I do that, obviously this will also work. Now I can say anything and everything will come there. So basically you do that using this REST path params. And then it's the use of query parameters. So query parameters are given as normal parameters of the function itself. So then these become query params in the HTTP service. So let me quickly get that code. Okay. So in this way. So let's see. So here I'm just modeling a search query where we give a keyword as a path parameter and other pagination parameters as query parameters. Like this was the sample request. You can see here the values are passed in this manner. So that is for the query parameters. Now it's for the payload data binding. So we have a new approach for that as well. So here also the payload is the value is passed as a normal parameter to the function. But now to distinguish it from a normal query parameter and a payload, so we annotate with the HTTP payload annotation. So let's quickly define that. Let's actually get the code here. You can see here we have to just put this annotation to the payload. So payload can be any supported type, like can be a string, JSON, a byte array for to extracting the binary values, and so on. So here, let's execute this and see. So let's send a text value for now. Okay. Yeah. So you can see here, it says upload with 5 bytes, which is the content I sent. So likewise, you can like conveniently map your payloads in this way as well. Then, as I mentioned, you can still use the explicit request response objects as well. So you just have to like this as the earlier one. This should be updated. So so like this example. Yeah. So in this manner, so you can still optionally provide the call and the request to explicitly like get the text payload or read the headers, other information like cookies and so on. And you can like manually send a response as well. So you can, if like optionally, if you want to handle any error that occurs while you are responding and so on, you can handle them in this place. So this functionality is still there. So that can be used as well. Now let's quickly go through the GraphQL features, which is new with Swan Lake. So in GraphQL, the main idea is you model your data in sort of like a basically like an object graph. So everything is connected, starting from a root query object. So you have fields in an object, and also the fields can be like scalar types or again objects as well. So with that, you can nest objects into multiple, as much as many levels as you want, and create a like complex graph of data. So that's very convenient when you have like a big data set and you want to represent it in like expose it to the outside. So you don't have to worry about individually creating like REST resources and so on, and figuring out the names and all these things, but you can directly expose it as an object graph. So so Ballerina has native support to this as well. So it's just a matter of creating a GraphQL service type, with the GraphQL listener. And from there, we can, again, similar to the HTTP scenario, we can define resource functions to basically represent the fields in the objects. So starting from the top level, the service fields, those are the fields that are in the implicit query object in GraphQL. So that's the top level one. From there, we can either return scalar values, or again, other objects are represented as service objects in Ballerina. So you can define another service object using a service class, give the implementation, and you can create objects of that and return it. So in GraphQL, so the main thing is this data is requested on demand. So it doesn't like the main advantage of that is there's no overfetching. So when you read a object, you will not like read all the properties in that object, but rather only when you access that field in using the incoming query, we will like optionally extract that field value. So if someone doesn't ask for that field value, we will not call that the field accessor, the resolver function for that field. We will not execute that, so that lookup will not be done. So this is useful, especially when there are like heavy database operations that are being executed and so on. So let's look at this small sample and see how it works. So in this service, we only have a single field called customer, and it also has a parameter. So in GraphQL, fields can have parameters as well, optionally, which can be used for additional querying ability. So let's see how this executes. So we have to send a GraphQL request for this endpoint now. So we had to send the request in a JSON payload in the GraphQL query format. So this is so this is a sample request. So I basically send a JSON content type, and inside the JSON payload, the query. This part is the actual GraphQL query. So it's sort of similar to the JSON, like a JSON object value, but it is not. It's a separate query format. So basically, you put that value here in this query field and send it out. So you can see we now get the response with that value. Likewise. So so that's the basics. That's basically the how you do a simple GraphQL service. And let's go to a more complicated GraphQL example as well. So this is so I'll quickly show you what it does. So it's basically modeling this like order processing scenario, like basically it's querying the order information that's there in a database, starting from an order, customer information, shipper information, and so on. So this is the basically the ER diagram for that data, basically that schema. So this will see how we model this using GraphQL. So here again, the initial service, the endpoint, we have a GraphQL service here. And the first one is basically looking up the order. So this is the endpoint. order information, and from there we go to the other places. So the first field the only field in the query object is this order field, and provide a order ID for it, which from that we return an object. So it's not a scalar type, but another object, order object, and return it. So here we model that using a Ballerina object. So the order class gives, the service class gives the implementation on how to create these objects. And we can see in this service class, we basically initialize the order data and populates, and the other resource functions are there to represent the fields, the resolve functions basically. It's simple as that. So in that, again, we look up the customer information from their order, and also the shipper, again, which are in turn objects as well. So they are also, if that field is requested by the user, we do another load custom operation and loads that and returns a customer object. So for that also we have a customer and a shipper service classes to define those objects as well. So here we do some database operations. We do a database query and gets the result and create the customer object using that data, as you can see here. So that means for each object, each order, we look up the order also from the database, as you can see here, load order, and create returns that object. And then again, optionally, we will look up the shipper and the customer objects from the database on demand if the user only asks for those fields. So that's basically how you model this. So like, as I mentioned before, you can nest it as much as possible, much as you want. You can go into the classes and create the operations as you need to load other ones, other objects. So in this way, it is very like extensible. So you can like conveniently add some more code and expand your object graph, like how you return the data. So let's see. Let's do a quick run and see how this works. Oh, it's a project, so let's do it. No, you can build it and run the whole project. Oops, we have this running already. So to request to send some GraphQL requests, I'm going to use this graphical UI Altair. It's just a nice way of sending GraphQL requests rather than sending a curl command. So I'm going to send this GraphQL query, which asks for the order object with the ID 1. And I'm asking for the nodes and the customer object. And inside that, I'm asking for the address field. So if you see, customer has two fields, name and address, and I'm only asking for the address. So likewise, you get the response in that way. So if I want the name also, I can say name. And also the shipper, I'm not getting the shipper information here. I can ask for the shipper as well. And the shipper has again name and phone, so I can ask for the name and the phone. So likewise. in that way, we can optionally like query the objects as we need. So other data as well, other order values. So yeah, so it's just a convenient way of modeling your data using GraphQL. So you can now easily use them with the Ballerina's inbuilt functionality. So now let me quickly go through the concurrency model information as well, and mention how it's related to the network side as well. So first of all, in the Ballerina concurrency model, so it's based on a lightweight concurrency construct called a strand. So like you find in other languages, you basically directly get thread access and so on. But we have another abstraction which is called a strand. And that works based on cooperative multitasking. So generally, the threads and the processor works with preemptive multitasking. Basically, the operating system scheduler swaps the threads out from the CPU cores to do the execution. But in the cooperative multitasking, basically the user level code will yield at certain places to give execution control to another execution construct. So here in the strands. So basically, in like every function in Ballerina is executed on a strand. So basically, the strand is actually the execution construct, the thread of execution. So in a single function, there can be one or more workers. A worker is the actual entity that executes where the strand executes on. So if you don't explicitly define any workers, there's a default worker in a function, and that is executed on the strand that it's assigned to. So this strand is, let's say, I'm calling another function from main, and then what happens is the current executing strands, current executing worker suspends, and that strands moves its execution to the calling function, and its worker is activated, and that strand is executed there. So it's the same strand when you call a sequence of functions like chain together. So from main, if you call the function foo, it's the same strand that was executed in the main function. Only after the foo function is finished executing, that worker is finished executing, the default worker, it'll return the execution back to main, and it'll resume the worker that's there in main with the same strand. So when you have multiple workers, so those are the concurrency constructs we have in the code. What happens is we basically create new strands to do the execution. So the default worker here, like for example, this client creation and this code works in the default worker, but these two other workers are creating new strands. And so then in this place, we have 3 strands executing. But by default, all these 3 strands are executing in a single group where they belong to a single execution thread, like operating system level thread. So that's the default policy that is there. We can customize this policy as well, as I will show you. By default, all these strands execute in the same thread. So that means these executions in the CPU are not actually happening parallelly, but at one time only a single strand is scheduled on the thread and others are suspended. So in this case, for example, in the main, so I'll quickly run it in my environment. So here, if I run this, so that means from the default worker, it will create the client, and these other two workers are concurrently executing to do these network operations. And it will return the result, and you can see the result here. So what happens is, so I mentioned this concurrency model is important for the non-blocking IO as well. So here these network operations are doing non-blocking IO operations. So when the main function is first invoked, there are 3 strands, and one will actually start executing. So so after the actually the default one starts executing first and create this HTTP client, and these two will be suspended at first. Then we do this check wait on W1. That will yield the current strand, its thread for other strands. Then one of these guys will start executing. And what it does is it does a network operation, the get operation. And when you, at this point, this is also a yield point to the strand. What happens is when you do a IO operation, it's a non-blocking IO operation. The IO operation is given to the operating system to do the IO operation, and we release the executing thread by releasing the strand. So that means it basically suspends this worker here, and the thread resource is released for any other strands that are out there. So at this point, when the network operation is happening, the scheduler we have inside can schedule the other strand to be executed here in the worker 2 to do its network operation. So while this is happening, this network operation is like initiated, immediately the execution switch to this, and this worker can do its network operation as well at the same time. So immediately these two will actually get executed parallel in this way, the IO operations. So we have, so if you look at what happened, we had a single thread, but both the IO operations are getting executed parallelly in the network. So when we get the response back through the operating system, this is this strand is resumed, and actually the return will happen. Also the same thing will happen here. It will resume and we get the responses. So in this way, we like conveniently handle these non-blocking IO operations without the user doing anything. So generally in other programming languages, we would use like a callback based mechanism to implement this pattern, where we do the execution, and when the IO operation is done, we will get it as a callback. But here, since we have our user space scheduler, and with this strands concept, we can actually suspend the execution and continue it later when the IO operation is done. So and also callback. So in other reactive programming language designs, patterns do the same thing. So without that complexity, with the same syntax, we can achieve the same thing. So efficient resource management can be done using this pattern. So but let's say if you actually want to execute, like let's say you have like CPU bound, CPU intensive operations, you want to actually execute parallelly in multiple cores that you have. But in the default mode, they are not actually executed parallelly, as I mentioned, but the thread will be assigned to one, and only after it's done, it will move to the other one. So if you actually want to execute them parallelly, you can do that by configuring the strands of these workers. So that is done by using this strand annotation for workers and other actions that you create workers. So there you can see this thread, the thread that is associated to it, where I'm getting it. by default, it's getting it's in the same group as the thread of the parent strand. That is the same, the strand of the default worker here. So then it will go to the same group. Here, if you say thread any, it will get a new, it will be allocated a new thread effectively. In the same way, if you annotate this as well, it will get allocated a new thread as well. So I'll just quickly demonstrate this as well. So if we do the default behavior, let's see how that will work. So we see now basically they would have executed one after another, and that's how the execution happened. Now let's do with by configuring the strands to actually have their own threads. So now we see the execution happen much faster because I have a multi-core machine here. So it happened faster, executes faster with the different threads. So yeah, that's actually a quick summary of the concurrency model as well. So you can see like how it encourages, like enhances the network programming aspects of Ballerina, and like it's like done out of the box in our services and our clients and so on. So you don't have to worry about it, but the optimal resource usage would be there. So yeah, you can get more information in our Learn pages, and the earlier GraphQL demo I mentioned can be found here as well. Yep, now I can take in questions. Let me stop my share so to check the questions. Okay. Understood. Okay. Okay. The first question is from Sebastian. Is this Helm 3 compatible? So we have temporarily removed the Helm functionality from Ballerina, but we will probably be bringing it back with some update to our code to cloud work. We couldn't update that yet, but we'll certainly look into that, the Helm functionality in the near future. And the other one is VS Code syntax authorization for GraphQL is using Swan Lake or older syntax. It does have the latest syntax highlighting. It's using Swan Lake or older syntax. It's using the new syntax basically. So in the GraphQL one, again in Swan Lake now all the services are using the new syntax. You can't use the older syntax for this. So everything is moved on to the new Swan Lake, like alpha level syntax.
Anjana, in that, I think the question, I guess we need to install Swan Lake and also update the Swan Lake compatible VS Code plugin to get that syntax.
Oh yeah, that's true. Yeah, you have to go and download the VS Code plugin from the website and install it. I think it's still not in the marketplace, I guess. So you had to manually go and download it from the website, Ballerina.io download, and install that. So yeah, with that you will get the latest syntax highlighting and all the code assists. Yeah. Yeah, Shakir said, looks like annotations are removed from the service. So yeah, annotations that did those operations that are related to new functionality are removed. But again, some of the other annotations are there, like as I mentioned, for like security and so on. Those are still there. So we still use annotations for other extended features. Other one, is there a way to test resource function without starting the service by test assignment unit test? I'm also not really sure about it. Samira, is there a functionality for that to test resource functions without starting a service?
Joe, I think Joe is on the call. He answered that, but let's see whether Joe can answer that. I'm also not sure actually. As far as I understand, we can't do that. We have to always start a service and.
Yeah, I think Joe is. Joe, what do you think?
Let's see.
Joe, we can't hear you. Are you saying anything? He's on mute, but. We'll see. Maybe Joe can send a chat. I think his audio is not working. Okay, we'll move on to the other question until Joe comes. Ricardo asks, are there available Ballerina plugins just for IntelliJ and VS Code? I think you're asking if we only have plugins for IntelliJ and VS Code. Yes, at the moment, it's only these two platforms we support. And actually, the most up-to-date one is VS Code. I think IntelliJ one is yet to be updated to Swan Lake, as I know. But it will be updated in the future. This question from Shakir, what minimum Java required to run Ballerina Swan Lake? So you need, first of all, when we install Ballerina, there's a package a Java runtime with it. So you need Java 11 to run Ballerina Swan Lake. So if you're using your own JDK, you need Java 11. Another question is, when do you plan to update the book? Yes. Still, there aren't plans to update right away, but yeah, maybe in the future. But yeah, currently I'm not working on that. So yeah, the book is a bit outdated. It's only supporting Ballerina 1. So yeah, I would recommend to use our user guide in the meantime. Is Benny's question answered?
Yeah, related to dynamic workers, right?
Okay, so yeah, you answered that, right? Okay, in the chat.
Manu and myself.
Okay, great. Thank you. Ricardo's question, I see Ballerina is easily suitable for implementing MSA business logic, microservice. What about covering several architecture sides, ESB, BPS, message broker? Was that answered earlier or not?
No, Anjana.
No, okay. Other architectural styles, So that you have the freedom to implement those on top of Ballerina, obviously. So like, for example, if you want to do like ESB style features, you can obviously use Ballerina. That means, like, for example, like pass-through scenarios, transformation, and so on. So Ballerina is obviously, being a programming language, you have the flexibility to do anything. If you're asking for any built-in functionality or anything like that, um, uh, there aren't any additional more special features for those, like the features provided like as services and so on. Those abstractions are the highest we go at the moment. uh, we don't like any other things that are on top of that you will have to implement. Like, for example, like there are we have made it easy to implement those scenarios. For example, if you want to do pass through, there are like operations in our services, service clients, and so on to do those easily. So you can use them, but you have to do some additional implementations to get the exact same behavior. BPS, I guess, I think you are talking about workflows and so on. Um, we uh, we had some plans to implement some long-running workflow features in Ballerina, but we stopped that. We may continue that in the future. Samira, do we have any plans for that? Or are we?
I guess the language designs are not on the schedule.
Yeah.
Maybe, yeah. There are plans, but not on the like upcoming schedules.
Yeah. So yeah, somewhere in the future it may come, but not in the near future. I guess. Yeah. Okay. Another question by Elondo. Is there any plan to support GraphQL mutation and subscription? Yes, but I guess not for Swan Lake, as I know. I think only the query features will be there for the Swan Lake release. That is correct, right, Samira?
Yes, Sanjana, that is correct.
Sure.
For Swan Lake release, we would only support query operations.
Yeah. Okay. Ilando, are big ints going to be supported in the near future? So big integers. I think we don't have a data type for big integers. So we have for
you're talking about decimal type.
Yeah, decimal. I'm not sure whether decimal will cover sort of like a big int scenario.
Yeah, I think decimal should cover most.
Yeah.
Okay. Probably most of the operations should be okay. Yeah. So yeah, if there are, maybe Yolanda can elaborate more if it's not, if decimal is not enough, or if there are scenarios like that. Yeah. Danishka is asking, will Ballerina integrator continue to update with Swan Lake release, or any other integration solution coming up with Swan Lake? I'm actually not sure about that. Anyone know the answer? Ballerina integrator support?
I think we need to talk to Kasun. Maybe that's a good question. We can ask on the Slack channel and we can get back to. Need to check with the integrate. That's the integrator team, right?
Yeah, we have to check on that and get back to you, Danishka. Ilondo came back. He said, I guess decimals are bounded. I guess that's true. There's a specific limit for decimal, right, guys?
It's 128 bit.
Yeah, I guess when you say big int, I guess it's unlimited, like unbounded integers. I guess Ilondo was asking in that case. Yeah. Yeah. So anyway, the I think the answer would be we don't have, I guess, yeah. So yeah, that's what he meant, definitely. So so the answer is, I guess, Samira, we don't have plans for that, right? That kind of data types.
Yes.
Maybe
So
maybe Ilondo, you can create an issue
Create a-
for that in a spec issue.
Yeah, I'll send the link to the repo.
Great. Yeah. You can definitely just request that and start a discussion there, like explain the possible use case. I'm sure you can justify that, and yeah, so can be possibly included in the future. Great. I guess those are the questions so far. Are there anything else from anyone, from others? I guess yeah, that's it. So yeah, if you have any other questions, please join the Slack channel and we can continue the discussion. Yeah. Okay then. That's it from me. Thank you.